Welcome back to my channel. So we are going to continue our resonance topic. In the previous video we have covered series resonance circuit. In that video we have derived a relation for frequency, then inductance, capacitance, and different quantities like impedance at resonance, etc. Now today in this video we are going to cover graphical part. Okay, so sometimes they ask for phasor diagram. In the exam they ask for draw the phasor diagram for series resonance circuit. So it is pretty simple. What we are supposed to do, we have to focus on the definition only. What definition says? Definition of series resonance, it says that in any circuit containing at least one inductor and capacitor is in resonance if its supply voltage is in phase with current. So same thing we are going to do, as this is a series circuit. So in the reference we will take current as a reference quantity, so it will be I0. Then supply voltage will be in phase with current. In phase means the phase angle between current and the voltage will be 0. Okay, now as we know, in the series circuit we have all over 4 voltages. Okay, so one voltage is supply voltage, other we have a voltage that is voltage across inductor, that is represented by VL. Then we have one more voltage that is across capacitor, that is represented by VC. And in this resonance VC is equal to VL, and in the phase diagram we can see that both are in opposite direction, so they will cancel out each other. So there will be only one voltage, that is your that is going to be your voltage across resistance. Okay, and that voltage across resistance is going to be equal to the supply voltage. That is the only condition of resonance. Okay, so this is all about the phasor diagram. I will repeat it again. What we will do, we will take a reference quantity current. So current we will draw horizontally, and voltage, supply voltage will be in phase with this horizontal current. Then we will draw a phasor upward, that will be your VL, voltage across inductor. Then we will draw phasor downward, that is voltage across capacitor. And as we know, these two voltages are going to cancel out each other, so the remaining voltage will be only VR voltage, that is going to be equal to voltage supply. As I have told you before that there are 4 voltages. So what 4 voltages? One voltage is voltage across resistance, then voltage across inductance, voltage across capacitance, and supply voltage. So all these quantities we are supposed to show in the phasor diagram, and this is how we will draw this. Okay, I hope you have understood. Now we will move for different part. Remaining part, that is a variation of different quantities with the frequency. So this is actually a bit of I can say moderate kind of topic. Sometimes they ask about it, but if you understand this thing, then you will find it that resonance is a very simple topic which you can easily cover it. As well as if you understand this topic, then it will be easy for you to do different numericals based on series resonance. So I would suggest that go through at least once, so that you can understand the basic relations between the quantities, and rest of you can prepare more important topics which are which are important for the exam point of view. Okay, so try to at least go through once. So variation of reactance with frequency. Now in this topic, what we are going to do, we are going to understand how the particular quantity is going to vary with frequency. Okay, so in here we are going to study about reactance. So we know that in the series circuit we are going to have two kinds of reactance. One is XL, and we know the formula for XL, that is 2 pi FL. So from the formula we can easily conclude that XL is directly proportional to frequency. That means what it says that as frequency will increase, the inductor will also increase. Means as frequency will vary, the inductor will also vary. So these two quantities are having linear relation. Okay, so if we draw graph for this, and here we are having frequency, and here we are going to have reactance. So if we talk about the inductance, so it will be like this. Okay, now we will go for capacitance, that is XC, and formula for XC is 1/2 pi FC. We can see that XC is inversely proportional with frequency. So that means as frequency will increase, capacitance will decrease. So it will look like almost like this. It is known as a rectangular hyperbola. This kind of relation is known as a rectangular hyperbola. So it is for XC. Okay, now if we want to calculate total reactance, so if you remember, total reactance is nothing but XL minus XC. That means we need to have minus XC. So for minus XC, what we are supposed to do? We have to go on the fourth quadrant. Okay, so this is your minus XC. Now XL minus XC, so how it will look like? It will look like almost this. So this point is nothing but F0, that is your resonant frequency. So this is how it's going to vary. It almost, I'm sorry, this part, about this part, it should go parallel with this, almost parallel. It should not intersect this. Okay, I'm bad in drawing, kindly bear with that. Okay, after that, variation of R with frequency. So resistance is what? Resistance is V upon I. So we can see that resistance is totally independent of frequency. So if frequency will vary, then this your resistance is going to be constant. So for resistance we will get a normal horizontal line. Okay, so it will look like this. After that, current. As I have told before in previous video, that in series resonance current is going to be I'm sorry, current is going to be maximum at resonance frequency. So let's take, if f naught is over here, we are taking frequency into horizontal and current at particle. So it will look like it's going to be maximum at resonance and it will decrease either side. So it will look like this. Okay, and this maximum current is going to be equal to I naught, that is V upon Z naught or V upon R. So this is the graph for current. It will look like this. Okay, after that impedance. So for impedance, as we know the formula for impedance, it is under root of R square plus XL minus XC whole square. Okay, so we can easily see it. If this is your F naught and F is over here, Z is here. So we have understood that in previous video. We have understood that the at resonance frequency, your impedance is going to be minimum. So graph for impedance is going to be look like this. And this will be Z naught, that is equal to R, and it is also known as dynamic impedance. Okay, so we can easily understand from this formula only that at the resonance condition, what happens? XL is equal to XC. Okay, so this term is going to be cancelled out at the resonance. So total impedance at resonance will be equal to R only. So that is how we are getting R. And as frequency increases or decreases, accordingly this factor will vary and this factor will vary, and we will get this kind of graph. It will increase either side like this. And here only we can easily understand that for the lower value of the frequency, XC will be greater than XL, and for higher value of the frequency, XL will be greater than XC, because XL is directly proportional to F, and XC is inversely proportional to F. That is how we are getting this thing. Okay, now we will go for power factor. For power factor, we get almost same kind of relation as we are getting in the current. Okay, so same kind of graph is also there, that is F naught, and power factor will be here. So I hope you remember at resonance power factor will be maximum. Yes, it will be unity. Why it is? Because at resonance phi is 0. Okay, as phi is 0, so power factor is cos phi, and cos 0 is 1. So that is how we are getting this. And as current vary, same way it will decrease both side. Okay, so this is how we are going to get the all values will vary like this. Okay, so let's draw a graph in which a common graph in which we can compare all quantities. Okay, let me try. I'm really not very good in drawing, so it's really hard for me, but I'm trying for you. Let's hope I will do it of better. Okay, so very first we will draw graph for resistance. It will be a normal horizontal line, as value of resistance will not vary, it will be a constant. Okay, then let's draw for current. So it will be maximum at resonance and it will decrease both sides. So this is your current. After that, let's draw for power factor. It will look like this. So it is power factor, and this portion will be for leading power factor and this portion will be for lagging power factor. You can show this also. And at the last we will draw for impedance. So it will be minimum at resonance and will look like this. Okay, so here this will give you Z equal to R, that will be Z naught, and here I naught will be V upon Z naught. If you mention this much, it's going to be more than sufficient. Okay, just draw a graph like this and explain one by one all quantities, what is the formula for particular quantity and how they are varying. That will be sufficient for you to get full marks. Okay, so let's conclude series resonance over here. Inductive reactance XL is equal to the capacitive reactance at resonance. So we all know this, and for this formula only we derive relation for frequency. XC will be equal to XL. This is most important condition for resonance. After that, total impedance of the circuit becomes minimum, and which is R. So at resonance, Z naught is going to be equal to R. After that, current will be maximum, and this will be equal to V upon R or V upon Z naught. Then voltage at resonance will be equal to voltage across resistance, because voltage across inductor will cancel voltage across capacitor. So that is why total supply voltage is going to be equal to VR. Okay, and after that, at resonance our circuit becomes purely resistive. Okay, so you can keep this thing in your mind. At resonance our circuit will be purely resistive, and because of that, phasor diagram phase angle will be 0. That means phi will be 0, and because of that we will have unity power factor. And this is formula for frequency. This is formula for series resonance frequency, that is F is equal to 1 upon under root of LC. Okay, so that's all for this video. We will cover more topics in coming videos. Thanks a lot for watching this.